Greetings, everybody. Welcome to our next webinar in series about mastering of AI implementation for property management. And today we will be mostly focusing on part 3 about process of model training. Actually, the tricky part, what a lot of people speak about with models, the training of these models, but actually, in all pipeline of delivery, the results of AI to, for example, property management, the model training is not the main one. It's important one, and we actually can skip it. But from the time consumption point of view, it's usually takes a little less of time, even, for example, comparing with data gathering and labeling. And today I will show you just in live demo mode how actually in some cases model training can be easily fast. My name is Pavel Filonov. I am an AI expert in Hyper IT company, and let me give you a brief about our today's agenda. So, after a short introduction, we will be speaking about two kinds of model and ML problem formulation. It's called supervised and unsupervised training. I will show the examples on concrete cases in which situation, what actual kind of model training do you need. After that, we will dive deep into the process of model training and actually what our points of influence of model results will be, for example, using the hyperware platform as a reference, and we will be speaking about threshold estimations, false positive numbers of reduction, and so on. And sometimes, usually people just think about one single model to rule them all. No, it's usually not the case. From practical cases, when you understand your particular problem more clearly, it usually makes sense to have the separate models of a separate kind of even the same kind, but for example, for different parts of the system, we want to discover and dive deep into it. So let's go straight with our plan. Speaking about introduction, we are the Hyper IT, a part of BPS Group. Our mission is provide the digital transformation for different stages of property management. Today we will be mostly focusing on operational stage, but BPS groups also provide the solutions starting from design through building and to operational stage as also. And I think it's a really important part to show how the AI and ML techniques can actually introduce this kind of digital transformation on different stages of property management. And about our webinar series, I hope it's not the first one, but if it's the first webinar in our series for you, we actually already cover some topics about business understanding and data preparation. Please feel free to find them in the recording and to catch up what we already achieved in understanding the stages of implementing AI techniques into the property management. And our today's stop is a process of model trainings. We will be speaking about with different kinds of models and different kinds of model trainings. And please subscribe to our channel because we are also ready to deliver you in the next months the following topics about model evaluation, deployment, and so on. So, about model training, and here I would like to cover the two main areas of different kinds of models and the training techniques. First one is unsupervised. Actually, it's really sometimes easy to start techniques, and this usually means what we do not need for manually labeled data. We just need the raw data without the answers, what's actually wrong, what actually is good. And in some cases, it is enough to achieve some useful results, but the actual number of problems which can be solved using the unsupervised techniques is less. I think the great example here will be the anomaly detection. Then we actually just want to highlight the system. We want from the system the highlighting of some time spans of some elements of the system where something goes wrong. For example, it's the good problem formulation for predictive maintenance. But even for unsupervised techniques with anomaly detection, problem formulation, actually data labeling also could help us. For example, all machine learning models usually have this situation called false positives. Then model can show as some possible anomaly situation, but the human expert will just label it as, oh, nothing wrong actually. It's a simple situation for us. It's a normal mode. And using even these labeling techniques, is it false positive or is it true positive, we can already use these labels to increase our model's performance and increase its metrics. For example, to decrease this number of false positives. So each notice from the model will show us some really anomalous situation which should be investigated, because sometimes it could lead to some huge amounts of costs, which can be just, but the problem can be easily solved on the early stages. But when we want to introduce some more context and some more information about what actually happens in our system, what kind of this anomaly, what class of it, what's the possible root causes, or what the possible consequences. Usually this leads us to the second area of supervised learning. And in this formulation, we actually need to start with data labeling and its mandatory steps here. And by labeling, usually we mean for example, time series data, select some time intervals, label them with what kind of situation is it. Is it normal or subnormal? Is it anomalous one? What kind actually this anomaly is? And using these supervised techniques, we can formulate so-called the classification problem. So the outputs of a model will be not just some anomalies happened, but also the possible labels, even with some kinds of probabilities. What the model thinks that, speaking about 95% of probability, this situation is somehow connected with malfunctioning of HVAC system and so on. And dealing with supervised problem model training, we actually need to add the new labels of data. Because it's the better practice when a model trained by labels which are actually their outputs. So the idea here will be to increase also the manual work to provide the new labels from the expert, what actually happens, even sometimes introduce the new classes. And I want to show this theoretical approach from the practical case, and would like to review goes through the scenario using the hyperware platform of anomaly detection and classification. So actually in hyperware, we have the both types of model training. We have unsupervised, which mainly used for anomaly detection, and we also have the supervised techniques, which were used if the labels are provided by users for anomaly classification. And the steps will be the following. I've already prepared some historical data we will be dealing today, and we will train and run actually the anomaly detection model to highlight us some potential situation. We can validate the results, we can manually label them, and also train the classification model, which for future scenarios, for future timestamps will predict if the situation is a normal or abnormal one, and if it is an abnormal, what actually it looks like, speaking about the previous labels. And here I would like to switch from the slides to the example of the system. Here I will show you the demo project on a real hyperware platform. And I've already prepared a little data set for our today's demo. Here we will be speaking about some kind of machinery, and we have the 4 parameters. which describes the current state of this machinery. It's some kind of voltage in the system. Uh, Also the voltage in another part, or maybe not the voltage, but the pressure and some kind of rotation mechanism. So even looking by our raw eye, we can see some kind of spikes on some kind of anomalous situation. And the interesting part here will also be the machine learning algorithm able to detect this kind of situation and to deal with them, provide us with automated notifications about something happens with our system. How this can be implemented with hyperware? Here we will be dealing with some kinds of event triggers. We will train the model to trigger some events when it will observe an anomalous situation. Here I have the empty list, and I will just create the new trigger. And we have the different types of. Here we'll cover the anomaly detection trigger. Now let's just put some simple names and description. And here I will be using the outlier detection algorithm. It's our mostly powerful algorithm in our system, which also can deal with multiple variables in one way. I need to choose the variables, and in this simple scenario, I can easily just put all 4 variables to be monitored. But actually, in some kinds of real scenarios, when we will be dealing about hundreds of parameters, variables from the system, it's a good idea to group them somehow and to train the separate anomaly detection models for separate groups of variables. Because, yeah, we can easily try to build just one model to rule them all, but usually from a practical point of view, this will just lead to the enormous amount of false positives. So it's a good idea, even on this stage, to introduce some kind of understanding of the system in its internals and to group the variables and to have the separate. Here we will call it event triggers. In theoretical approach, you can call it models for different groups. I need also to set the interval. Here we will consider the historical scenario. So I can just set some interval. I will choose approximately half of a year, the data from the 2024. I will also use the defaults here, but if you understand more deeply the velocity of data changes, you can actually provide the custom configuration. And actually the important topic here will be about this threshold. This threshold is really important for anomaly detection models because in some situations we can have a lot amounts of false positive. Let's just test it. In test scenario, actually the model just gathered the data and began the training procedure. And after that, it also provides the inference results. And maybe you just understand what all process took less than 5 seconds. And usually in nowadays, when we're speaking about the models, maybe you heard about this large models, which takes the days or even weeks to train. Yeah, it is the case for a large amounts of data. But when we deal in about more specific areas and more specific groups of variables, actually we will be dealing just with subsets of raw data. And using modern hardware and modern machine learning techniques, the training procedure actually goes really fast. And this speed mostly achieved by the actual data, which was already prepared in the system with the same time grid, with the aggregates, and so on. So the actual training procedure is sometimes really fast. But here we also have results. For about half-year interval, the algorithm found 16 anomalies. And sometimes, for example, in your situation, with your data, it sometimes could show you hundreds of anomalies. And this usually means that's a lot of false positives. Because here we just use the default parameters for our model. The threshold actually allows us to reduce the number of anomalies which will be found by model. Only the anomaly situation which are really different from the normal one could be observed by increasing this threshold. Let me just experiment a little bit. If I increase this threshold from 30 to 50, let's speak about some kind of percentage from the scale from 0 to 100. And I could also retest my configuration, try to understand what will be the difference of found anomalies. And we actually see what the number of anomalies decreased. The 12, from my perspective, is also maybe a little bit large amount to be manually dealing with to investigate each of the situation. So I can try the next threshold, let's try 60, and also make our test again. And here we can have 9 anomalies for a time span of a half a year. I think it's good enough for my system because in some situation, for example, if I try to put the threshold for 90%, I think maybe there will not be anomalies at all in our system. So using and updating this threshold, we can actually just a little bit tune our model, how it will deal with results, because actually we want some anomalies to investigate with. And this means in this configuration, the threshold of 90 is really not good enough. Let's go back to the 60, retest it again. Each time I press the test button, actually the new model retrained. And after the configuration is good enough for me, I can just apply this trigger. And usually this means on the background part of the system, the machine learning model begin this training loop, retraining loop, and provide the anomalous events for this particular variables we are selected for this test trigger. And we can also find it here. Usually it takes some time. I also prepared for you the copy of this project where our events already happens. And here we have actually some few thousands of them on the scale of the whole year. And we can investigate each of this trigger, try to find out what actually happens. And in some situation, the human expert can try and look what actually happens here, because all parameters in the ranges, there are no gaps, no spikes. And usually this means that sometimes the machine learning models just make mistakes. And we can also use this positive feedback loop to provide the information for model what, no, this actually the mistake. Let's label it. And here we have this special labeled false positives. And using these labels, the anomaly detector actually can provide the better result with less of false positives. But this can be achieved only by human labeling of these false positives. Some of them here are actually already labeled not just by some anomalies, but with some predefined classes. And these classes can be configured for each project in Hyperware platform, because usually we have separate anomaly classes for separate part of the system. Here we already have a resolution, but it's not just the anomaly, it's something like high pressure. We can just take a look on the pressure one, and we actually see that it's some kind of not just spikes, but for some period of time it just goes up or some level shift here. And actually, these results are already the joint results from the both models, because on every trigger, we actually train not the single, but the two models. The single one is for just anomaly detection, and the second model, the first one, and the second model is for anomaly classification. By default, the second model is disabled, but it will be enabled automatically after the human expert introduce these classifications. And the maybe first few thousands of events should be classified manually by the humans, by the users of the system, but the next events which will be produced by the event trigger will be already classified automatically. Where still possible some kind of errors here, because the classification models also have the mistakes. But these mistakes also can be fixed. For example, if this specific anomaly was not about the high pressure, we can manually change the label, and on the next iteration of model retraining, the new data will be used to improve actual outcomes. So these are the results of actually two models, which was trained in the background. And for example, for anomaly detection models, it's usually really easy and fast to train and retrain on every stage. Speaking about classification, it's sometimes not so easy. Even in this scenario, it sometimes took from 5 to 10 minutes, but it's fully automated, and usually user just need to provide the right labels to the events which was detected by the first model. And on automatical schedule, the new classification model will use this data, and the new provided result will be augmented with possible classes for our system. So here our main scenario. We just take a look on each of those steps. And as you can see, it actually took us less, I think, than 5 or 10 minutes. But I show you on real system with what model training stage, if this model training already automated and integrated in your platform, the model training by itself usually took less than a few minutes. Mostly depends on the amount of data. For example, if we try to train the model to monitor thousands of variables with history about the few years and using the time window about few minutes, yeah, it's to take a time. But because of the process goes on the background stage, we will just see the actual results, and we'll just achieve the useful results of model detections here. So let's go to the main takeaways for today's webinar. Sometimes, and usually not sometimes, in most of the cases, when we're speaking about machine learning models, we should consider not the single model for all. Yeah, it could use the single algorithms, but the specific models, for example, for specific groups of variables or for specific tasks, could be considered separately. And usually this leads to a better performance of these models, speaking not only about the time consumption, but also about the metrics, performance and metrics. We definitely should evaluate the model results, and here I just show you how this can be easily done using the Hyperware UI. But on our next webinar, we'll be talking about more automated way of this model evaluation and validation techniques, because in some cases we actually need to dive deep into what happens when the model finished the training stage and begin the inference stage, and maybe we can even suggest some better defaults for thresholds and the model parameters. And even after we already have the trained model and we run it, we can adjust it in no time, usually just use live reconfiguration. Because some parameters usually influence the model internals. But here I show you the threshold, and speaking about the threshold, usually the thresholds are not influence the model internals, but just the pre-processing stage of model outputs. And this means we can easily reconfigure the threshold of model detection and can in no time achieve the better performance using this positive feedback loop, even sometimes in continuous scenario. So This was the main idea to show you what actual in integrated environment the process of model training can be easily done if the algorithms is already prepared, it was chosen for the right tasks, the data was also prepared, and this whole system can orchestrate in an easy way. Uh, and just a little announce for our next webinar. We will be speaking more about these processes, about model evaluation, and in some scenarios of poor metrics, what actually can be done to improve there, because usually it's not about we choosing the right model. It's also some kind of a tricky part, because data scientists usually talk about the different types of model. But from the practical business-oriented way of thinking, it's mostly not about choosing the right model, but choosing the right metrics and choose the right procedure of model evaluation. Does it really help us to achieve our business metrics, or it didn't provide us with any help at all? And this is why this model evaluation stage is really important to understand the actual business impact of the ways the AI implemented in modern systems. So, and I think it's a good time for questions and answers. Please feel free to write your answers in the chat. I will just monitor it. Maybe some questions already we have in the chat. And I will give you a few minutes. Maybe you have a question in mind and you just need some time to put it in a messenger. Also, feel free to ask questions not only about our today's topic, but maybe the previous one or even the future. I will be glad to share my experience from practice about different stages of AI implementation. And also, this webinar will be accessible through the recordings. Please feel free to ask any question or leave any comments on our LinkedIn page. We also read them and will help you to find the answers. So your experience with AI implementation for your product can be also as easy as I just show you using the Hyperware platform. Thank you for your attention, and see you on our next webinar speaking about model evaluation. My name is Pavel Filonov, and I was glad to share with you this observation about model training. See you. Bye.